So today, we're going to discuss the greatest common factor, or we're going to factor out the greatest common factor out of some numbers as a review, but then more out of algebraic expressions. And every time I start with greatest common factor, it is probably the most confused thing with least common multiple. And both of these have to be read from the back. You have to understand what each word means. And if I start from the back and I say that I want to have a factor, that is a number or quantity to make a product. So 6 has factors of 2 and 3, or 1 and 6. You notice none of those numbers are bigger than 6. If I ask for a multiple, least common multiple, if I ask for a multiple of 6, we have 6, 12, 18. They are equal or greater. So I start off with greatest common factors are always equal to or smaller than the number. Okay? Common means it's the same in each term. It means it's the same, common. I have in common with you that we're both human beings. We're both humans. Common. The last thing is the word greatest. And again, looking left, greatest means the biggest. So if we use that thought process as we look and do a little review here, the greatest common factor of some numbers, okay? And I start with two numbers, 12 and 14. And often students will just immediately write down 2 because they're both even. While 2 is guaranteed to be a factor, you have to make sure it's the greatest. And I do that in my process by breaking it into its primes. So I break 12 into 3 times 4, and I break 14 into 2 times 7. 7 into our prime, so I'm done there. 4 breaks down to 2 and 2, and then I write in order. 2 times 2 times 3, which is 12, and 2 times 7. That is a factor of the primes, and this is one term, which is 12, 14, and 2 times 7. They are equivalent, so I'm using my rule of algebra, they're equivalent. And these are all the factors in red there, shown here. And the question is, what's common? Well, the only thing in both of these that's exactly the same is 1, 2. And therefore, the greatest common factor is 2. Now, one of the old methods is to list out all the positive integer factors, and you look for the one that matches. And that works for problems like this. And we'll do it on the next one too to make sure you see how it works. For 12 and 18, I immediately jump to the primes. 2 times 2 times 3 is equivalent to 12. And 18 is 2 times 3 times 3. And again, those are the factors. Here's one term, here's the other term. What's common? And you see in the green arrows, 2 and 3 and 2 and 3. So the greatest common factor is 2 times 3. That's one thing. But we don't write 2 times 3, we write the greatest common factor is 6. And again, if you list them, you can see that 6 is the biggest, the greatest factor that's common in both. And here at the bottom I have the last one. I want to find the greatest common factor of 8 and 24. 8 is 2 cubed. I wrote that out. 24 is 2 cubed times 3. So what's common? The 3 2's. The 3 2's are common. So 2 times 2 times 2 is the greatest common factor, which we write as 8. Again, we start by making factors, then we look for common, then we make sure we have the greatest. But what about algebraic expressions? So I made my first term 12xy. Now it's an algebraic expression, and I made my second term 14x squared. And from the previous example, we knew 2 times 2 times 3 are the primes. Well, x and y are both factors also in the first term. And on the second term, 14x squared is 2 times 7, but x squared is xx, both factors. So what's common here? Well, the 2 and the x are common. So the greatest common factor in these is 2x. And to make sure we see that as what's left, 2 and 3 and y, if you multiply those together, can be written as 6y. 7 and 1x can be written 7x. And the common factor of 2x is here. Is 2x times 6y still 12xy? Yep. Is 2x times 7x still 14x squared? Yes, again. So, can 12xy plus 14x squared, a 2-term algebraic expression, be factored? The answer is yes. That's what we're trying to do. And we have to remember our distributive property. A times b plus c is equivalent to ab plus ac. See how the a is equivalent? And it can end up being on the outside. We can do the distributive property backwards, a lot of times is what students tell me. So again, if I start with that expression, 12xy plus 14x squared, and I write it out as 2xy And instead of writing comma, we know that we can write that as plus. And we look at that, this two-term expression over here, still equivalent to the initial one. And what's common? Well, the 2x, like we said. And I can pull that out front. And what's that leave? It leaves me the 6y, the plus, and the 7x. And if I distribute it, just to make sure, this is my answer. And I check it by distributing, and it matches, so I know they're equivalent. And I never can make a math mistake if I have equivalency in expressions. 3 plus 1 is the same as 4. 2x times the quantity of 6y plus 7x is equivalent to 12xy plus 14x squared. And the important part is I go from a two-term expression to a one-term expression. This is one thing. 2x times this junk. That is one thing, and that's going to be important for us in manipulating equations. So, if I start with this example on the left, 2ax minus 6ay, two terms right now. What's common? Again, I wrote out the factors, and I look, and I find 2a is common in both of these. So I pull the 2a out. What's left? Well, the x, and you can put a 1 here. I know a lot of students will say, oh, I want to make sure my math works, and they'll put a 1 there. It's an okay thing to do initially, but we want to get away with it. But 2 times 1 is still 2. So, and then we pull out, and we're left with the 3y. And the sign has to be negative. And if I distribute, I get 2ax minus 6ay, which is the same. And again, that's my solution. On the other side, I have something a little more complicated. I have no numeric coefficients. It is a complete algebraic expression with all variables. I still take the time, initially, as we learn, to write it up. A squared is AA, x squared is xx. And I write out a cubed and x cubed, and I write out x to the 4th in the last term. And then I see what's exactly the same. They all share 1a. They all share 2 x's. And very quickly, you're going to see systems and shortcuts. But initially, I think writing this out really makes a difference. A step I usually don't ever write out is if we agree axx is common. I wrote that as the beginning of each term. And that's what I pulled out. And that left the single a, the double ax, and the 2 x's. And then I can write it using exponents again. And if I distribute this, it has to be the same as the initial algebraic expression. In this case, I went from 3 terms and factored to, again, 1 term. Ax squared times the stuff. All the things in parentheses. Now, I have 2 examples here, and maybe if you want to try it, you can pause it. All I'm going to do here is quickly turn to the board and write out the common factor outside first, and then I'm going to work my way down. I see 4 and 2, and I know 2 comes out. That's the greatest common factor. A cubed, a squared, so I can take 2a's. B4 and just single b to the 1, which means I can take b to the 1. X cubed, x3 is 4, so I take x cubed. That leaves me a 2 here, because 2 times 2 make 4. I need another a, because a times a squared is a cubed. I need 3 b's, and again, maybe I got this a little tight. This is x cubed. And I need no x's. So that expression is done. And also, I've seen students do this. They would cross out the numbers, and that's fine. Over here, I have the 2. I have 2 a's. I have the b. I took 3 of the 4 x's. That left 1 x. So I end up with just 1 x. And again, to check the math, I simply distribute and make sure it's the same as the initial green expression. Now, 2 terms to a 2a squared bx cubed times this, which is 1 term. But 2 terms outside leaves 2 terms in the parentheses. When you look at this part, this factor has 2 terms. Over here, there's 3 terms. So I immediately can write this. And I want to pull out what's common, and I want to write here what's left. And again, we're factoring, so we're making something times something, making a product. And again, this time the factor is 2a squared, y squared, and this is one of the big mistakes right here. If the a squared, y squared come out, those are 1. You take a 2 out of 6, that leaves a factor of 3. On the next term, we get a 2 gone. I have an ay. On the last term, I have a 2a squared y. And again, you can check this by distributing and make sure it's exactly the same expression as it was in the beginning. If you're not seeing this, write out all the terms like we did in the last problem. And find the common factors. And it takes time. And eventually you'll start to see shortcuts yourself. And you can start picking them out. Again, the big thing here is that your final answer and the initial algebraic expression have to be equivalent. And if you never allow yourself to have those two not be equivalent, you'll never break an algebra rule.